Hey everyone, I think we've got connectivity now. Great to see everyone. My name is Sam Dutton. I'm a developer advocate, work for Google Chrome DevRel team in London. I'm going to be talking about WebRTC, really giving a quick overview of the project. But please, we really want to hear your experiences working with the APIs and so on. So please feel free to come up to me afterwards or get in touch if you have any questions. These slides will be online at that address. I'm sorry they're a PDF, but there we go. This is a huge project, and I'm really going to go into a little tiny bit of detail about it. I just wanted to get an idea first of what you guys are working on. Is there anyone in the room who's actually built an app using getUserMedia? Is that a no one? Has anyone done anything with RTC peer connection? That looks like no one as well. That's fantastic. So, yeah, and if you know all the abbreviations in the bottom line, well, I really feel sorry for you. Anyway, so I think the internet really kicked off, the web really kicked off this kind of information revolution. As we know, it enabled us to share information, made information sharing really easy, to create stuff, to distribute it, publish it, and also to discover information, media services, and to consume those things. The one thing that is missing from this picture is kind of the simple ability to do human communication, with audio and video, so voice and video. I think that's one of the last really big challenges for the web, and that's what we call real-time communication, RTC for short. So in the past, RTC has been kind of corporate and expensive. It's difficult to install real-time communication systems. It can be really, really pricey, to pay someone to come and work in-house or to license technology. Either way, it becomes an expensive option and really difficult to integrate with other webs. We've got all this information stuff on the web, all these services, and it's been really hard to integrate that stuff. What we have now on the web, of course, are plugins. The problem with these is that in many ways they can be kind of cumbersome to deal with. The quality is not always great. But there's also, of course, the problem with plugins and separate apps, separate from the browser, that they need to be found and downloaded and installed. And it's really hard to get users to do that, let alone keep them up to date. Now, what we have essentially for real-time communication is Flash, and despite all Flash's benefits and qualities, it has been problematic in some ways with real-time communication. The WebRTC project really hopes to come up with something, and I think already has, that is an improvement on that. So what's happened is that a bunch of people across industries, so carrier companies, communication providers, and obviously browser vendors, including Google, have come together. So this is like Mozilla, Opera, Cisco, Ericsson, Google, and others. So they've come together and built this thing called WebRTC. So essentially this is a kind of package of technologies that the core of which has been actually, the code has been written by people working for Google at vast cost. And this has been open sourced and made available freely, which, I think is a kind of miracle anyway, but that's a great thing. And, what's now developing is this kind of open community of people who are working on the WebRTC project, trying to to define and standardize and give us a sense of give us some really great APIs out of that. I mean, the bottom line, if you're building web apps, is that this is a way to do low-cost audio and video and have that built right in, that communication built right into your web apps. What this means is that because it's an open source project, freely available, there are no license fees for the developer, no license fees for the user. It's really straightforward to integrate WebRTC into your app. It's just another API, set of APIs. And of course, it's easier for people to use your service because they don't need to download any extra stuff. They just need to go to the address or install the web app that you've made. And again, the point of this is this idea of person-to-person communication, because it kind of sounds obvious, but this is kind of the foundation of how we interact in real life off the web. Without it, the web is kind of limited. It should be as natural to do kind of face-to-face human communication in a web app as it is to like enter text in a text input, which in some ways I think is not very natural. So I think what we'll get is these kind of person-to-person communication built into apps in this kind of seamless way, and kind of simple corporate stuff like better customer support. I think WebRTC will enable more frequent person-to-person interaction. Maybe in some good ways, like this might be the end of kind of endless email conversations where a person-to-person chat could do well, and just these systems that use audio and video for all kinds of interactions. It will be very interesting to know what the effect on telephony will be with WebRTC. That remains to be seen. So we have these kind of obvious use cases for WebRTC at the moment. Stuff like Google Hangouts and Skype, obviously. But I mean, I think what interests me is what developers will do with these APIs that goes beyond that kind of obvious stuff. We've seen this, this explosion in these media APIs over the last few months. We had the video element, the audio element, stuff like web audio, the track element, media source, and related stuff like Canvas, WebGL, and doing things with CSS, and now. We got like USB APIs and gamepad APIs, so this really rich kind of dynamic experiences where these APIs come up against each other. Just a case in point, this is kind of nothing to do with WebRTC in a sense, but to me it shows the kind of the wonders of the unexpected, really. So this, let me just put it on full screen. So this guy from Google cycled around the campus in Mountain View, and he took video on his bike, and he got GPS coordinates. It's pretty straightforward stuff. So he created this like XML kind of track that displayed where he'd been. I put that together with the track element and on a video element, and so we're getting like synchronized video and map. So you can move along the map, and as you can see below, it changes the position in the video. And if you change the position in the video, it changes the position on the map, which is pretty straightforward stuff. But what I like about that is the track API was all about it was going to be all about stuff to do with captions and subtitles. No one thought about it as something that might coordinate with the Maps API, and I really like the way we're getting that with these APIs. This kind of what happens when these things come together in unexpected ways. Something more kind of, I guess, what you might expect from WebRTC. This is a demo we produced at Google I/O earlier this year. This is a company called Tether. They produce this kind of disaster communications kit, which comes in a little briefcase. And what this does is it uses the Open BTS cell platform, which is a way to create your own ad hoc cell phone network. And that enables communication from any kind of phone to their box. And then they use WebRTC for communication between that via a kind of gateway, so to speak, with a computer. So what you've got there is, telephony without infrastructure, which is I think it's pretty amazing, pretty radical, but also extremely useful in that context for disaster communications. As you can imagine, we had a lot of trouble trying to get a license for this, in central San Francisco. But anyway, but it's great in the field. Tokbox, another company, have just released, this doesn't really work very well, but they've just released their own kind of video platform, which is really straightforward to put a way to put video in your apps. And there's just a little sample there of the quality. I don't know if you can even see that, but anyway, the point is that the WebRTC is really looking better than the kind of comparable Flash stream, which is great. So just to kind of rewind a bit, what we've had is this series of innovations on the web relating to networking. Obviously, something like, it's funny that Ajax was invented in, I think 98 for OWA, and, it took 6 years to actually get any traction. But anyway, and more recently we've had sockets giving us bidirectional communication with the server. What WebRTC does, and this is, as I'll explain, there's a huge potential beyond video and audio with this. WebRTC gives us the ability to do peer-to-peer communication. It's worth mentioning, actually, in this context, that we're seeing kind of interesting stuff happening on the web with networking. We've got in the packaged apps for Chrome, we've got the ability now to set up a use the socket API to do set up a UDP or TCP sessions, we've got huge power in that. Also, you can do this similar stuff with Firefox plugins. So, what does real-time communication need? Well, the first thing you need with real-time communication, audio and video, is obviously some way to get the streaming data in real time. So, that stuff, that's complex, those three things, like real time and streaming and, doing all this stuff with audio or video. And then you need some mechanism, obviously, to communicate the data. The third part is a kind of separate process where you need to exchange what are called session control messages. So this is stuff about networking information and about media information. So the capabilities of peers on the network and the kind of content they're dealing with. So things like resolution and formats and so on. And I'll talk in some detail about that later. So the first part of this is fulfilled with, I don't know if anyone's used this, but it's getUserMedia is this really straightforward method. And that's all you need. That bit of code there will get streaming content from your webcam and then display it in a video element on your page. It's really straightforward. Let me show you an example of that now. So if we go to Chrome, you can see it's working there. And sorry, I didn't stop there, but it forces you to give permission to do that. And then if we go to Firefox, it's actually connecting. You can see a similar process, and there we go. And let's have a look at Opera as well, if that's connecting. I don't know if that's going to work, but anyway, it's running. There we go. So we've got it in Opera, Firefox, and Chrome, running very similar code. And what I like about that also is that it's just beginning to appear on mobiles. Ericsson's created the browser, kind of WebKit browser for Android and iOS, and that runs getUserMedia as well, which is really neat. Let's just dive into that. I think I'll just quit from there. Quit from Firefox as well. So let's go back here to the example running in Chrome, and let's have a look at the code for that. What I've done is I've exposed the stream object. Maybe let's go back to the code. So when you get the media from a streaming source, you create this stream object. So let's have a look at a bit of detail about what that looks like. So I've exposed that. as a global there. And then if we just look at that, I'll just bump up the size a bit. Is that pretty visible? Is that okay? Yeah, okay. So the stream object isn't very complicated. This is a media stream object, and what it has there essentially is an audio tracks property, which gives you the various audio tracks that you might have, and a video tracks property, which does the same for video. It has one method, which is stop, and if I call that, you can see what it does there. So we go back here, and yeah, it's stopped getting video. Now, if we look at audio tracks, you'll see that there's nothing there because we set in the config it was just video. So there is a zero-length media stream track list there. There are various events that go with that if you remove streams and so on, and then there's a unique identifier for that. And hold on. And then if we look at the video tracks, we'll see that we've got one video track, which is as we would hope. And yeah, the kind of this is video, and it gives you a label, which is the name of the camera that it came with. And obviously, each of those, we can have multiple input streams, as I'll explain. So, you could have different sources providing different audio and video. And again, you've got events that go with all that stuff. Let's go back to here. So there's the code again. And yeah, there's a kind of summary of the different components. So what you can imagine are situations where, in fact, you have more than one input that needs to be synchronized. So kind of obvious cases, like if you're doing video conferencing, you might be sharing an app, you might have microphone input, video input, multiple cameras, and so on and so on. I've heard some really interesting use cases for this. Someone was telling me they're doing something with WebRTC with training, with medical training, like they need multiple cameras, and they're using that for synchronized kind of communication of this stuff, which is great. We've looked at that. I just wanted to show a couple of other fun things. I don't know if anyone's seen these, but I thought I'd show them anyway. There've been also already some really remarkable kind of fun demos of things you can do with getUserMedia. So yeah, as you can see, the process there was to ask me permission to use the camera. And yeah, so this is just doing stacks of different effects using getMedia, UserMedia, and then applying filters to those. And you can take photos as well, do sort of crazy things there. I really like this example, this little getUserMedia xylophone. So again, allowing the browser to get a camera stream coming in there. I don't think the audio is working on this, so I might unplug the audio. Is the audio, can that be turned on? I don't know. Maybe not. Okay, so look, I'll just run it off this. You can probably hear it. So it's really straightforward. It's just diffing it's getting the input from getUserMedia, and then using that to work out which way you're moving across the stream, and then you can play this microphone, this xylophone, sorry, as you go. Just really straightforward stuff, but all done using getUserMedia. We've seen a few more things like that. Oh, sorry, there's one more I just needed to show you because I am in the process of giving a presentation. This is some guy who sent this to us. Hang on, I've got to allow this. So what this does is it enables you to control a presentation by moving your hands around. It's a bit hyperactive, but you get the general idea. What's happened in like about 3 weeks ago is that we got integration with getUserMedia and WebAudio, and this is really stunning because it means you can use the input from your microphone as an input node for WebAudio, and that gives you a huge amount of power to then do stuff, to work on the sound that's coming through there. Already heard some really interesting thoughts about, using this for music making. The possibility of radio stations providing material and like audio in uncompressed formats that then, stuff can go into web audio. Stuff, interesting ideas like that. So let's just have a quick look at some of the stuff that's come through with that. So there's a couple of demos here built by my colleague Chris Wilson, and he's done several interesting things. This is kind of really straightforward. This is getting input from the mic and then doing pitch detection on it. So did Paul Kinlan show this morning? But anyway, I'll do it again. So in case you missed it. It's just doing really straightforward pitch detection on the input there. There's some other really lovely things he's done with where we've got audio inputs, creating these beautiful visualizations. But also, if we turn on, sorry, it's a bit hard to do this because the mic is next to the speakers, but we can do stacks of effects on the audio, like reverb and delay and so on. It's a bit hard because the mic is right next to the speakers. But lovely stuff from Chris Wilson. I think I'll just move on to one more here, built by Paul Lewis. What this does is that it ties in with WebGL, so the visuals are controlled by the audio. So you get the general idea. So again, this beautiful thing where the APIs come together and do something that no one kind of expected really. So we're getting that just from getUserMedia kind of coming up against other APIs. So like I say, we need to get the media, which I've just shown some examples of, and then we need to communicate it, and then we need to do this signaling process as well. So the APIs of WebRTC are media stream, which I've showed, and then RTC peer connection, which is the API that deals with actually communicating audio and video data. I'll go into some detail about that. And then there's this third API, which hasn't been implemented in Chrome yet, but has just appeared in Firefox and Aurora and the Nightlies. What data channel allows you to do is to communicate arbitrary streaming data. So this is really huge potential for kind of peer-to-peer sharing of any kind of streaming content, as well as file sharing. Like I say, that's in Firefox now, and will be coming to Chrome. And the point about it is that the latency is very, very low. So obviously you can do this stuff with WebSocket, but data channel is going to make this, as they say, a kind of speed of light problem where we're getting very close to the physical limits of what's possible. So here's a slightly dodgy diagram, but it kind of gives you a sense of what the stack looks like for WebRTC. You will see reports in the news, people talking about WebRTC like implementation, where really they're just talking about getUserMedia. WebRTC is the whole stack, and the real-time communication stuff, the peer connection stuff, is a huge part of it. The other component of real-time communication that you need is not defined by the WebRTC project. And these are the processes of peer discovery and signaling. So peer discovery is simply the business of, finding the person to speak to and getting their details. So this is like the equivalent of finding a telephone number or contacting someone, you know, via Google Plus or Facebook or whatever. The signaling process is the process of exchanging network information and also media information. Now, this is deliberately not defined by the WebRTC project. You can use whatever mechanisms you like for signaling. People have done examples using WebSocket, Node.js or whatever, and other examples using XHR plus the Google Data Channel API. And you can use whatever protocols you want, so XMPP, SIP, or whatever. This is, again, not defined in the WebRTC project, this signaling part, how you exchange that information. So, yeah, it's peer-to-peer, but, you know, we're still going to need servers for this stuff. There's still this process of setting up sessions, of coordinating communication, and we're always going to need servers to do that. This is the architecture. It's what we call JSEP, for the way that it's been designed, where the processes of signaling are kept outside the WebRTC spec. This simply shows that, you know, that process goes through this kind of cloud thing, and then the aim is to set up streaming of media directly between the two browsers. One thing that diagram, just going back to that diagram, shows, you know, it's kind of one-to-one. But there's no reason why peer connection can't be multi-party. The question is how you want to do that, you know, whether you want situations where it would make more sense to have all the peers connecting to all the other peers, other situations where you want, you know, where you've got a huge number of peers where you're going to need to connect via some kind of centralized gateway. So, you know, the examples, the kind of samples that people have built are all one-to-one at the moment, but there's no reason why it has to be like that. It can be multi-party. So I want to go into a bit of detail about RTC peer connection. This is kind of the meat of the project, really. This is like the biggest part. The slightly embarrassing thing about it is that the name of this API has gone through various iterations. The point is now that we're on a prefixed name, which is WebKit RTC peer connection, and when everything's settled and standardized, we'll move to RTC peer connection, and that will be the name of the object. So, you know, it has been through these iterations, and apologies for the name changes. This is a kind of diagram of what RTC peer connection does. And the kind of two things about this, I guess, is that it does a lot. There's a lot in RTC peer connection to do, particularly with coping with the vagaries of video and particularly voice communication. So things like echo cancellation, noise cancelling, gain equalization, this thing called dynamic jitter buffering, which is simply the business of efficiently buffering data so that you don't get what's called jittering, the kind of hiccuping in the video process. This diagram actually has codecs in it, but this is the Chrome implementation. There's nothing in the WebRTC specs that define that, you know, that specifies codecs. So we're seeing different codecs coming through. A particular one to be aware of is that the current audio codecs shown here is ISAC, but of course, if people, that's designed for voice, and if people are doing stuff with music, they're better off with something else. So I think the probability is that will move to Opus, which is working really well and you know, being used by Mozilla. So with the signaling process, the first part of the process is that you need to establish your network identity. What happens is that imagine like a caller and a callee, just like two people trying to have a video chat. So the caller creates their RTC peer connection object. If that works, the callback for that is past what's called an ICE candidate. So this is essentially a candidate for you know, a network connection. And then the so the caller, sorry, that says callee sends ice candidate. The caller sends like a string version, a string version of the ice candidate blob data to the callee, and from that the callee can now create what's called a remote ice candidate, which in other words is information about the caller's network, and they can add it to, again, what's called their remote description. And if that all happens, great, things can work. Now, the other part of the process is that the caller and the callee send each other information about media and capabilities. So this is stuff to do with what media the browser is capable of coping with, and the formats and codecs and so on for the media that is going to be communicated. So this is kind of similar process, making what's called an offer, sending the offer, and then the callee making their answer and sending their answer back to the original caller, and then they have that information and can start a call. So when you instantiate an RTC peer connection object, you have a config object which specifies, I'll talk a little bit more detail about this later actually, external servers, what are called stun servers, which can be used to get external network information. I'll talk about that later. And then a call is started by instantiating the peer connection object, and I'll go into some detail about that. And then, I mean, we have here this signaling channel, which is this kind of imaginary object, you know, whether we're using WebSocket or whatever for signaling, that has an on-message attribute, and then we create a handler for that. I think the easiest way to kind of explain this a bit is to actually show you the code in the spec. There's a really nice little sample here. So I'll try and talk through this. It is fairly, there's not a huge amount of code there, but it is a little bit complex. So I'll try and talk through this. So what's happening, it's a kind of expanded version of what I just shown you. So we create this signaling channel, and let's actually just go to that first. So if we look at the code here for the signaling channel, when a message is received, if there isn't a peer connection object, an RTC peer connection object, the start method is called with false as the argument, meaning that this is not the caller. So this browser is not the caller. This browser is actually, what this means is that this browser has received a call from another browser. It's received a message from a browser that wants to initiate a call. What happens then is it creates a signal variable by parsing the event data, and then it looks at that and checks if the signal has an STP value. This means that it's a remote description. So this is the description of the capabilities. In this case, it'd be the capabilities of the remote browser. If otherwise, it means it's information, it's network information, it's ICE candidate information, and it adds, in that case, it's ICE candidate information from that serialized data. So let's go back and see what happens in start now. So start is called, you know, with true if this is the caller, and first thing that happens that is to create an RTC peer connection object with the configuration information. And then when an ICE candidate is returned by RTC peer connection, then the signaling, this kind of imaginary signaling channel, can actually send the stringified data for that. So using the candidate property of the event that's returned when the ICE candidate is created. When a remote, this is, what I love about this next bit is that it's so damn simple. Like when the remote stream begins arriving, so like the add stream event is called, to set up remote view in this code is simply the video element. that's on a page. And it just simply needs to set the source of that from the stream property of the event that's returned from the onAdStream handler. So pretty straightforward. And then the next bit of the code is using the getUserMedia stuff that I showed before. It's setting, in this example, there's something called self-view, which is like the, so you can see what the person you're talking to is seeing. It adds that as the source for that video element. And then it adds the stream to the peer connection object. Now, if this browser is the caller, it creates an offer, and then the callback for that sets the local description and also sends then the stringified version of the SDP. So this is again the information about local media and capabilities. Otherwise, it creates its actually received this offer and it needs to create an answer, and so then it does that with the remote description it has, and then again calls the got description callback after that. So let's actually have a look at that in action. I'd say this is a really good place to start. If you want to get your head around WebRTC, this is a good example simply because there is no signaling involved in this. This is a kind of useless demo because what it's essentially doing is it's a page calling itself. It's creating two RTC peer connection objects in the same page. And if we look at the code for that, you could see, I mean, what I like about this is that it's actually creating the two RTC peer connection objects which communicate with each other and setting up the whole thing, setting the values for the, and setting the source for the video elements, and doing that in like less than 100 lines of code, which is pretty neat. So if we start this off, what's happening is that we're getting the getUserMedia is being called, and we accept that. And then when we call, what we're getting is the process I just talked through, but happening within the page. And then we're getting a video chat with ourselves, which is kind of useless, but it's good for demoing what's going on. And like I say, I would recommend if you want to get your head around WebRTC, that's a really good place to start, because a lot of the complexity actually can be in the signaling process of setting up, WebSockets and communicating that data and so on. Just going back to servers for the moment. So we've got obviously this process of user discovery and communication. That's, it's always going to be necessary. You need to do something, whether you're Skyping or doing Google Hangout, you need to be able to communicate with someone to say, I'd like to start having a video chat with you. There's this signaling process, which I've described, which can be done, like I say, the protocols and the mechanisms aren't defined by the WebRTC project. You can do that in any way you want. The other part of the server requirement for WebRTC is to cope with the vagaries of networks. So essentially there's two parts to this. You've got what are called stun servers, which enable you to do NAT traversal, so getting into and out of stuff like any situation where there's a network address translation or firewalls and so on. This essentially is a way of getting an external address for your computer or whatever it is that's behind a firewall. The intention, obviously, of WebRTC is to have communication using RTP, UDP between peers. But if all else fails, you can use what are called turn servers. Turn servers are kind of simply relay servers. I think I've got a diagram of this, which doesn't really show you much, but the point about it is that if WebRTC is designed to cope with the failure of direct communication. And the way it does that is to go via one of these relay servers. The nice thing about the turn and stun servers is that they're actually pretty dumb. They don't have to do a lot. So, there's not a huge requirement for those to be kind of beefy machines taking a lot of work. That mechanism, by the way, that kind of framework is called ICE, whereby you can cope with these various network problems. So at the moment, you might have noticed that in the most recent version of Google Chrome, WebRTC is now available without a flag. It's there, it's up and running, so you've got getUserMedia and RTC, well, WebKit RTC peer connection in stable. Opera's got getUserMedia. Firefox, like I showed, has getUserMedia in the nightlies, and Aurora, and now just since I think it's last week, 2 weeks ago, has RTC peer connection and data channel. And the aim is for these to be in Firefox stable, in Firefox 18 in, I think it's in January of 2013. Internet Explorer, you've got Chrome Frame, which I've used actually, and it works a treat. It's slightly bizarre looking at like IE8 or whatever running WebRTC, but it works, which is great. And yeah, I was hoping to demo this, but anyway, Ericsson have released this Bowser browser for iOS and Android, which does WebRTC. It's a slightly earlier version, the protocols they're using, and the method they're using for that, but they've actually built the first mobile, version of a browser that copes with WebRTC. And this is the natural home for WebRTC, I think, of course, on mobile devices, because it's all about communication, personal communication. There's also been some great stuff. People are doing things with the C++ APIs. So there's I saw an interesting example. Someone had built some good stuff using Qt with the WebRTC C++ APIs. So have a look at that stuff. I'd love to see some more interesting things with that. See people kind of creating clients on servers, so to speak, and stuff like that. So loads of potential there. And there's a video on YouTube of what the guys working on the Qt stuff have done. In terms of security, we're using secure protocols anyway. But I think, in a sense, the most secure thing about WebRTC is the fact that there are no plugins, that it's built into the browser. And, the point about this is also that you get these quick updates, which, clearly we're not seeing with plugins that tend to get left behind. There is a rather long document, if you want to have a look at it, on the IETF, and then there's a section in the spec which just says TBD, if you look at the W3C spec for the security. But yeah, obviously there are, the secure protocols and just the business of using plugins do make this, I think, very secure relative to any other alternative. I'd just like to kind of finish by actually showing an example of the real thing. I was hoping to do this with like someone in the audience or something, but there's just no way it's going to work with the connectivity that we've got at the moment. So I'm sorry about this again. I'm going to have a phone call with myself, which is slightly dodgy. So what I've done here is I've instantiated, like in this tab, RTC peer connection, and I'm getting media via getUserMedia. I'm going to open this link in another tab. It'll let me do that. And then if we go to the other tab, chug. Sorry, I'll have to open that app again because I just did it twice. When I go to this page, it redirects to give you a unique identifier there. Let's just try that again. And open that in a new tab. And then if I go to the new tab, you've got to pretend this is someone else in another part of the world having a conversation with me, as opposed to me next to myself. As you can, you can hear the sort of terrible audio kind of echo effects if I try and turn on the audio. So what you've got there is the video chat, like the local view and the remote view on the same page. This is a really good place. This is the sort of first place to go if you want to see the whole stack of WebRTC with signaling, apprtc.appspot.com. A really nice little demo there. That I won't show these now because I'm slightly running out of time, but the lovely demo there, integrating WebRTC with WebGL and these kind of old televisions, which is beautiful. And please have a look at this. This is something we had commissioned for Google I/O. It's an old version of the Who Am I game where you're a celebrity and you have to guess who you are, and it's definitely worth a go. It's quite a laugh. So if you want to find out more about the project, a couple of places to look. WebRTC.org is the kind of home of the WebRTC project. There's a really active group. They're a friendly bunch. The people who live on that group are really open to questions. A lot of stuff goes on Twitter, and there's a Google Plus account as well. All of those worth looking. If you want to find out more about WebRTC or get started on building something, I'd really recommend looking at the videos like Justin Uberti did a great one in Google I/O, the Colin Jennings video from Ericsson, a couple of HTML5 rocks articles, and there's a book now, a really nice little e-book. It's about sort of like €8 or less, I think. So it's a great bit of documentation there. There's various standards. Obviously, WebRTC has standards in the IETF for protocols and so on, and then the web APIs are standardized, like the W3C, and there's some other related specs there. So getUserMedia and the JSEP architecture and so on. What we really want is for people to try out these APIs and give us for you to give us your feedback when you've tried them out. So please, again, file bugs when you find them, because there's certainly going to be some. We're in the early stages of this, and we really want to make sure that we're getting all kinds of use cases and getting feedback for those. So these slides are at webrtc.pdf. And what I'm looking forward to now is, we've really had mostly, I think, people involved with kind of telephony, video conferencing, that sort of stuff. What's going to be great is, when we've got web developers playing with these APIs, I think that's when we're going to see some really, really creative stuff. So thanks very much. Please feel free to ask me questions now, or come and talk to me later, or get in touch with me, and I'll see what I can do to help. So any questions now? Yeah. Can you show the link of the slides? Oh yeah, sure. Sorry. The slides are there, and I'm sorry it's a PDF. But anyway, that's what it is. They're all the links are linked, so to speak, in the PDF. Any other questions? Yes.
Can you connect to streams that are not on your local PC, not connected to your webcam, but to your DSP stream somewhere?
Yeah, I meant to say something about that. Yeah, the answer is yes. The idea is essentially that you could use any kind of streaming data, and I think there's a lot of potential for that. So streaming from recorded video or whatever, and also other kinds of arbitrary data. I think it'd be really interesting also with data channel. There's kind of obvious like gaming stuff there, but also potential for kind of scientific applications. I can imagine. Imagine being able to get like CERN data, the Large Hadron Collider, direct in your browser. That would be pretty cool. But some use cases I've heard of are to do with like music making and news gathering. The BBC's talked about some stuff with getting user-generated content, but also mixing that in with pre-recorded stuff. So yes, not just live from your webcam. Anyone else? feel like I'm staring into the sun. Anyway. Okay, if no more questions, thanks so much, and we'll see you guys around, see what you make of this stuff. Thank you.